and I'm Ben, one of the organizers of iOS Dev TH Meetup. So today we have two sessions, one from Michael and another one from Fred, but another speaker is not here yet. He said that BTS is too crowded today. So we are going to start the first session, and I would like to thank the sponsor here, the studio, who provides us the space here. So basically, Studio is like the website that you can find an online course or the workshop, and you can like take the course about the tech skills. Yep. So if you have free time, you can like check on their website, Studio. Yep. And okay, so please welcome Michael about the first session, fun with debugging, right?
That's. Okay, so good night, everyone. So good night, everyone. My name is Michael. So thank you for the organizer and Ben and Bas, the one from Singapore, invite me to speak in here. And today I will bring up about fun debugging in iOS. Before that, I will explain about little bit about me. My name is Michael. I coming from Indonesia, basically. So, but my face look like Thai, so sometimes people didn't recognize me. And also, I used to work in as a React Native engineer before. I moved to iOS engineer at Echo Communication. They changed the name as MET now, and recently I just joined as engineer at Akoda. On me. So at first, why we want to talk about debugging? So basically, if you know about debug, is coming from the word bug. So bug is kind of insect that annoy us. Let's say a cockroach, and when you want to remove it from you in front of you, you need to kill it immediately, right? But it solves the problem quickly, but sometimes it will the next day it will coming more and more. And without the debugging, we don't know exactly the root cause where does the cockroach is coming from. It may be coming from because you keep your trash outside of your terrace and you never throw it, or something else. So that's why I hope that this session can help you to learn more about analyzing some of these things. My topics, we have around 4 topics. First is about LLDB debugging. The second one is about memory debugging, UI debugging, and logging itself. LLDB debugging, so it stands from the low-level debugging. It's kind of official debugging for Xcode itself. You can debug any kind of application from like macOS or Swift, Objective-C, C, C++. That supported by the Xcode itself. And most of you probably familiar with this kind of basic debugging. You can just put a breakpoint, the blue breakpoint, on one of the line of the code that you want to stop it. Let's say halt the execution at specific point, and you can use any kind of expression or even like a PO, print object, P, or help and another command. Basically, there are a lot of expressions. Some of them I never use it, but normally what we did, we use like on the bottom right, we use a PO to print out the object that we want, and it will give us more context information on what kind of things that we want to see inside. And we can also see the stack trace on the left side on your screen on your Xcode navigator. You can see a lot of flow, basically, where does this things comes from previously, and you can see more depth analyze on it actually. On the bottom left panel, you can also observing the current variable state, either in the class perspective or in the function itself. So let's say you want to use stop or halt the execution on breakpoint on some line, and you want to observe at that point what is the current variable look like, what is the content inside, and you can open up its object or its properties, and you can see through it basically. And on of the navigator, we can see that there are multiple buttons. Most of the time, we know that this is a continue button. We have a step over. Step over means you try to execute the next line instead of going inside, deep down to the function inside, which is we are using step in, or even we can want to step out from the current function itself. The next two things, view hierarchy debugger and object debugger, I will explain later on the another topics. And now we move to kind of more advanced way to debug. Sometimes we don't know that we actually can move breakpoint to a group kind of a user. It's quite tedious if you want to, you have a breakpoint, you create a new breakpoint every time, but you want to start a new project. Somehow you need to recreate again. So you can actually move this one, and the same breakpoint will open in any project automatically. It will help you in terms of debugging in your another project as well. Another thing is you can share your breakpoint to your college. Let's say you want to share it to your friend in the work or your teammate project. You can share the breakpoint, and it will have the same. It will set up in the workspace in the workspace, and they can open and they can see the breakpoint that we want actually. The next things we also can double click on the blue breakpoint, and we can put more context on it, like putting the name, putting the condition, how many times you want to ignore this debugging until it's executed, or even some action inside it. And the action itself, it have like multiple action that interesting to try, like Apple script, capture GPU frame, debugger command, log message, tell command, and sound. Each type of action will have a different kind of options below each action to fill up what you need to do. Basically, you can, if it's sound, they will give you some more options to do what kind of sounds do you want, and maybe that you're interested on gaming project, you can put sound to, let's say, you want to stop at this point, what kind of sound that you want to perform that tell you, notify you there something problems itself. If you click on the options on automatically continue, it means this debugging will not halt your execution, but it will automatically continue the process. However, if you put some action like a sound, you will actually notice what was when is actually coming. The next thing is about the generic breakpoint. Is quite a little bit more. Actually Apple provide us preserved breakpoint that we can use basically. There are multiple breakpoints that they provide for us. If you click on the breakpoint navigator, you click plus, you will see this kind of 7 breakpoint that provided an Xcode, latest Xcode. Previously, they don't have, I think OpenGL, they don't have it, and runtime issue maybe, I kind of forgot. But the latest one, they have like this kind of 7 breakpoint. And I will go through some of this breakpoint. Basically, I will not explain about the test failure breakpoint, constraint error breakpoint, and runtime issue breakpoint on OpenGL. Was on because it's least used by some people. But for information like a test failure breakpoint, if you have like test and you want to know where the assertion is coming from, with this one, it will navigate directly to your test, which one is failing. Basically, it's quite useful as well. And let's go to one of these errors. Sometimes you found this error on your debugger. Command debugger output console, you can see NS layout constraints will attempt to recover some things, and the Apple give us a hint in here, make a symbolic breakpoint with this kind of symbol to catch the error. Basically, this one will let I say, once you put that one, you will get more stack trace basically. So to inform you exactly where does this coming from, when you rerun the application again, you get at the point you get this error, it will stop the execution. You will get more backtrace on the stack trace. You can navigate properly to get more information. It will help you not only for UI view alert for unjustifiable constraints, but maybe collection view flow layout, maybe UI table view alert for layout, and many more. Basically, there are a lot of symbols that maybe I haven't found it, but you guys can also explore more about this. This is one of the example that I just recently caught. You get a warning, was told the layout is visible cell somethings, and actually Apple give us hint, make a symbolic breakpoint. So I put this breakpoint on our breakpoint, and then I can get more context on it when we run the application. So this is the way we put the name. Just put the symbol that we need in there, and then run it. We can. This is one of good candidate that we want to share among the college in the work. Actually, it will help you to notify your college if actually we have this kind of warning that we need to resolve. Yeah, this is the example. If I run the problem, I will get more stack trace on the left side. where is it actually performed? It turns out it performed in the setup middle button about layout below if needed. Maybe something wrong in when I want to layouting some constraints in there or something like this. So it will notify us. We need to take a look more in here. This is the exact location that we need to find out more about what was happened, why this warning is coming. We can also print out the argument when this things happens by using dollar symbol argument. The first argument, you will see more context, what kind of UI view that uh, um, caused this problem, basically. Okay. So next, yeah, I think we can continue. Okay. So next, talking about shift error breakpoint, it will pause your application when the throw statement is hit, basically. Uh, it will add more clarity when we debug some things. So same as before, another breakpoint, it will have like some stack trace that's helpful for us and taking us to the exact location when the exact moment when the error is thrown. But there are some downside of it. It only throw your application is the one who throw an error. If the error is coming from the framework like a foundation, this breakpoint will not be hit, basically. And yeah, yeah. Yeah, this is something that I haven't found. So yeah, the reason. Cool. So additional information. Yeah. Okay. So we can continue to the next question. So exception breakpoint. What have is truly an exception. So, so exception breakpoint, we try to help to identify some of identified error like red signal. Sometimes we have a problem. You see your application is crashing. We terminated some things, and as an exception, we can use this one actually to catch the exception that happened, and it will give us more context. It's yeah. Wait a moment. Yeah, example like this, you will see a red error, but you don't have more context. You just know it's main. What is with that? What happened with my UI application main, right? Once we get the exception breakpoint, we can know. Oh, turns out the user default try to set up an object. which is not supported by the place file. This will help you to know exactly what was happened with your application, and it's very helpful for us to identify the issue with the exception breakpoint. And this breakpoint is one of the candidate that we can use to share among colleagues, and we can also move to our group user. So next time you open a new project, it will always there breakpoint. Yeah, just like some tips for that. We will move to the memory debugging. So normally what we heard about the memory debugging, people will talk about instruments, right? So some people will try to using instruments that we can have a lot of tools in here that we can use, like allocations, leaks, core animations, time profiler as well. That can be very useful for us to debug for the application that we run. However, sometimes, so the uses that we want to find, like a track down problems, we can find memory problems by record the retain count that happened when you run the application and you want to record it. You put the selection to record the retain count, so it will automatically give you more context on it. You can also find a GPU performance of your applications by using core animation to track the FPS that you want. You can also analyze another performance that I also haven't like explored more, but in general, these kind of things that's very helpful by using instruments. But the problem is most of us kind of bit intimidated by the word of instruments, because sometimes when you know about instruments, you don't want to use it. You feel like when you use it, sometimes the application doesn't work well, doesn't recording well. Sometimes the app is not sync with the instrument. Sometimes you know quit the Xcode, restart the Xcode, or doing this kind of things that make you feel okay, just drop. We don't need to use instruments. We try just to normal way, or maybe if we don't feel it, maybe we don't need to use instruments at all, something like this. And it may lead us to doesn't know exactly what was happening with the our application basically. But there are some easy way that can help us. It's very easy. Is using the init basically. Using the init on its place, it will tell us exactly if our object it has been deallocated or not. But however, there are still some problems that we occur that we are using this one. It's quite tedious. You write the init and everywhere, and maybe we don't need it, and also still lack of information for analyzing the root problem. What happened? Why it's not getting called? You don't know exactly. It doesn't help you much for it, even though it will tell you why if this object is not allocated properly, and you need more like detective skills to analyze the problems. It's quite hard for us, so for some developers as well, for doing this kind of things, especially if you are joining a new place. You just see the legacy code, you don't know everything about it, somehow have a problem like this, and you don't know where to start. Right. So one of the things that I just get recently, I also just learned from recently, and thanks for Andre as well for about this. And this one is object graph debugger. It's try to help us to capture the state of the instance on specific time. Basically, it helps us to, let's say you are on the screen A, you go to screen B, and you want to capture the state of the screen B. What happened in the heap memory on this one on the left side? So this is the place that every memory stored in the heap, and in the middle you will see like the illustration of your memory that you select on the left panel. And the right side, we can see the backtrace as well, what happened. But on the right side, we need to have a proper way to get this kind of things by setting up our scheme, by we check up the malloc scribble and malloc stack logging. So these two options will give us more options to provide live allocations and backtrace to our object graph debugger before we get more information on the backtrace as well. And we can also filter by click on this button on the bottom left. There's a button for filter only on memory leak. You will see a purple color. This purple indicator is very useful to know that there is something wrong with your instances on the object graph debugger. And it's more easier. Some people doesn't know that we can actually go to navigator and put the triangle there and go to the runtime. We'll have more as well. You can have a lot of information which one is causing the problem at the runtime basically. But next in the visualization we can see like this. Sometimes if we take a look on the one of the instances that have a problem, if the arrow is indicated the flow who retain who, and if we see on the number of the arrow it indicates how many times it has been retained by another object. So we will see there's a problem on that one. And by clicking the arrow, we can actually have more context what happened inside. So there are some tips for object graph debugger, but don't only focus on the purple indicator. Sometimes there are some ghost memory, ghost instance that hanging around in your application, but you don't know that this actually no one able to delocate it because it's just stuck there. Like let's say you go to screen A, go to screen B, and you try to go to screen C, and you go back again, and you capture this of the screen B, and you turns out the screen C is still in there in the object graph debugger, but there is no purple indicator, and you need to know why the screen C is not the screen C view controller is not getting deallocated, but you don't have any there is no purple indicator. It means this instance is hanging around in our application, and we need to find out more information about it. So it's quite helpful for find the memory leak, but also you need to have more detective skills in terms of analyzing what was happened with your application, and but at least you know exactly where to start for that one. This one is least useful from the object, but it's good for know the knowledge behind it. I rarely use it just one time, but it doesn't help me much, but it's quite helpful to know. So it's try to, like a zombie, try to extend the lifetime of someone. Basically, if you are human and you die and you become a zombie, it means you extending your own lifetime. But actually, you die anyway. And by using this one, it's normally useful if you have something like error like a bad access, right? And by extending this object will try to keep alive, and you will have more context on it on the debug console. Basically, later on, just tick on the zombie objects, and when you run the application again, go to that exact point or locations, you will get some console into your debugging console, something like this. But it's quite least helpful, like I said. So sometimes I don't really understand what's the meaning behind it. It's just like memory address, the instance, something's happened. But if you combine it with the instruments, it may help you more context for it. I haven't tried it personally, but it maybe if you like to explore more, you can explore by yourself. How does it happens, and it may help you for doing this one. I read some article in the documentation from developer Apple official documentation. You need to take a look of three things. What was the type of the object, and what was the message that sent by activate the zombie object. The second thing is when is the object actually delocated. So you need to explore, analyze it, when is it happening, and why this is happening, and how was it object used. Maybe after it's delocated, you use it wrong. Maybe somehow the object that you want, you still assign it to somewhere, or you doing something with that object, but actually it has been delocated or something like that. So it will help you to know if you know this kind of three thumbs up rule, basically. And last thing is memory panel. If you go into the uh, second one from the right, you will go the memory panel. When you turn on, you will see this kind of memory usage and some of the other things. And if we analyze it properly, that is quite helpful. This is one of application that I made by SwiftUI, basically, but I haven't released it, just inform you guys. So when you go to the first panel, and you want to go to the second screen, and you dismiss it back. Normally, what you need to see on the memory panel is like the memory usage. It should be decreased on the last layer, because once you go the first to the second one, yes, it's normal. You will increase it, but once you go back or dismiss it, it should be reduced. However, if we see it in our memory panel, if the usage is like increasing instead of decreasing, it means you know, oh, something wrong in here, and you can combine it with object graph debugger or another instruments or another things. It's so maybe it's quite helpful for us to understanding more or easy to analyze for memory debugging. Yeah, like I said before, this one. So next to the UI debugging, one before go to the more advanced one. So when you go to the bottom left, actually we can have a quick look to see the live preview. When you tap on the space on the property that have the view, you can see exactly what is the view at that time. It's quite helpful if you try to retain the view, but somehow the view is not there. It's not assigned to a frame, so you want to know, oh, is the view actually is there or not? So you try to debug it, put the breakpoint, and type space in there. Oh, the view is there. So what was happened? So you know exactly what at least you know that the view is there, but somehow it doesn't set on the frame, something like this. Another thing is the view hierarchy debugger. That maybe some of you already familiar with this one. You can capture the view hierarchy. You know exactly the view stack from the bottom layer until the upper layer. But actually, you can do more by minimize it, because some of the layer on the most bottom you may don't need it, like UI window skin or another things. Maybe we don't need it. You can minimize it with the button on the bottom right, and then you can take a look on the second button, the blue one, to only focus on the constraint. Maybe you want to only take a look on the constraint issue, so you can take a look on that one. Also, this one, if you a bit annoyed with the wireframes, you can just put the contents. You can see only the contents of it without the wireframes. If you want it. Uh, so Pixel restarting. So okay. So next we can go to this one. So if you want to see the clip layer that outside the boundaries of your phone, you can tap on the most bottom left, and you will can analyze more what happened in the at that time. Maybe you want to analyze, is it something wrong with is the object that you want is actually has been ready before it actually show to your screen. Basically, you can take more information on this one basically. And it's hard for you to focus on something, you can refill in the bug navigator. It will help you to go to the stack trace, where is actually located, under which object that have this kind of UI label property in here. And also you can print the description of it. Is at the UI level, blah blah blah. Maybe if you subclass from some another class, it will show exactly what kind of class that have this information. And if you focus on the same things, purple indicator, it means there are something wrong on it. Maybe it's constraint issue and another things. It's more advanced. It's rarely people know about this way. So if you go to the simulator, you see on this debug, you will see have some of tools, color blended layers, color copied image, color misaligned image, and color off-screen render. So I will show you what happens with my own pet project here. If you click here, you will see the red color here. If we change to the copied image, I don't have it. Actually, it will represent by the blue color. And if we take to the last one, the off-screen rendered, you will see the some yellow color. Same as the color misaligned image is also represented by the yellow color as well, but it's on different purpose. Misaligned image is of course for an image, but for the off-screen rendering, it's maybe a layer of the content itself. Okay, so for color blended layers, so as I mentioned before, it is represented by red color. It indicates that iOS is trying to have more power to try to blend your layer. Basically, if you have like two view on top of each other, if it is just like black and white, the black one is can easily render it directly. But if you have like an of transparency over it, the iOS need to have extra power energy to try to mix it together, and it may cause some performance issue. It may be it's okay if only one or two things, because normally even like I think the navigation bar I think also have the red one as well by default. But if you notice it is darker, the color is more dark, it means it may impact a lot So you can take a look by activate this one and take a look on the FPS performance basically. Let's say this example, you put a lot of code here for add a layer, shadow, and everything, or another thing, so opacity and everything, and it looks good as we design. But when we turn on the red one, we see the this kind of things basically, red color on the its UI that we have. When we try to investigate more with the instruments, we can see the FPS is dropping here, like 15, 21, 23 when you try to scroll, and it's quite laggy at that time. It means something wrong with that. So there are some method that people explained. It's about using the shoot rasterize, helping you to catching the result of the layer itself. By doing that one, you can see on the video, it will much more faster because you are using the catched result basically. It's one of the solution, but actually maybe you have another solution. It can help you to improve the performance itself. It is not an absolute solutions. It maybe have a lot of solutions that you can help you, but at least this is one of the solutions that are pretty famous out there. And once we do that, we can see the FPS is it's high. Become 60, around 60, 58, and the GPU usage is only 23%. So it increased the performance of the scrolling itself on its stable view layer, something like this. And the offset rendering. So this one represented by the yellow color. This means that somehow iOS need to second rendering, and it asking CPU to perform and helping the GPU to perform the rendering. This can lead excessive performance on the view layer, and this is because there is some excessive usage of some CA layer. Sometimes we like to put a shadow, corner radius, or load a huge image size because they give us like built-in functionality easily for us to like just use it, and it's easy convenient for us. But actually, sometimes it can make excessive usage of it if you are not careful. If you are using like, let's say, table view. Yes, there are a lot of solutions. Maybe one of the solution in Shadow is different. Let's say you can just use a image background that have a shadow and a corner radius directly. You can use a stretchable image and put it in there. It will help you. You don't need to throw in the shadow and everything. By the background image, it will help you. Or you can using the UI image graphic render something to create the image beforehand. Or you can also throw a shadow path for the layer. It's like several solutions, but they have like pros and cons on each other. So you can like pick one based on the research as well. And misaligned image is almost similar as off-screen rendering, but it's solely focused on the images. iOS, if you set something like boundaries like image view, like say pixel for let's say 100 multiply 100, right? And if your image is 100 and 100, it's easy for iOS to map it one and one map, boom, and there's no problem. But if the pixel is different with the space that we prepare for the user, they need some stretching to make it go into the boundaries of the image view, and it causes some performance even though we don't notice it a lot. So it's quite outdated for magenta color. I think from iOS 14 they replaced all with the yellow color. So I'm not sure that's true or not, but as I researched yesterday, right now they don't have the magenta representation anymore on the Xcode 12 and the S14. But previously, if you're still using Xcode 11, if you see the purple color, it means you have too much degrading performance on these misaligned images. And yeah, like I said, the pixel reserve that we reserve for the image is not easily to map. This is why the misaligned image occur. Color copied image is useful, but it's good for knowledge, represented by blue color. Just like a knowledge, it's because Apple GPU only can able to parse 32-bit color formats, but sometimes you cannot control the source come. You maybe want to display the image coming from the online source that have the format TIFF or JPEG that have a different format than the one Apple GPU can process it. And it causes this color copied image happening, and it represented by the blue color. But it's rarely happen. I never see it personally. But this is the good knowledge for us to understand it, why it happens. And some of the solution is we can ask the designer actually provide us the 32-bit color format, or even we convert them in the background thread. Right, basically using the UI image something like there's some API from Apple that can help you to convert it, the image itself. However, there are some, as I read, there are some drawback issue if you are just trying to convert them manually on the client side. So it's always better that we're trying to communicate the designer, hey, provide me this kind of things for iOS because of this, so we can explain them the trade-off. For the logging, this is the last topic. It's quite quick. So before we hand over to Fred, normally what we do, we just using NSLog or print, and it's a lot of things we need to do with that one. Sometimes we forgot to remove it. Sometimes we put bad formatting in there. Sometimes you just randomly put some joke in there, and you never want to remove it, and it costs another developer that come in to debug it, see this kind of print or NSLog statement that maybe not necessary at all. So using console app is one of the recommendation from Apple for logging, basically, even though mostly they are using this one for logging on kind of in the production mode, because you can, if you install your application, you plug it in your cable on put console app, you can see a lot of logging information on your console app, like some of the stuff in here, and on the production mode. So it help you to catch some error that maybe it's not happening when you write it in the debug mode. So you code, you just use a breakpoint, you just use a normal print statement or whatever else that I explained before, but it never happens in reality. So it just like we get a report from a production mode, and by using console app, we can actually maybe simulate the same thing on the production, and we can get more information on which exactly it happens. And start from iOS 13, iOS Apple keep us like OS log is a it's a unified logging approach that recommended by Apple itself. It's Apple API for logging. They have multiple log level types like default, info, debug, error, and fault. And you can also protect your secret data if some another people want to log your applications and their own phone, but you don't want to disclose it. You can use percentage sign private, and it will help to secure the data inside actually. And we can really more utilize console app, even though it's not that, maybe you still need to use another debugging approach like I mentioned before, like a print statement or breakpoint, but it may be still useful to use this one as well. In the iOS 14, they provide us a class, logger class. It helps to, you don't need to write your own encapsulated object to encapsulate all of these things, the method before, but they provide us a new API, new class to help us to have more readability in terms of using the API. Basically, it helps us to have string interpolation and literals and everything, but it's only support on iOS 14. So maybe if you thought you just want use to your own pet project, it may be very useful, but it's for your project in the work, it may be not that useful at all. So, but if you still want to use the normal print, you can use custom string convertible. I think most of you guys already know about this. Or maybe some of you that doesn't know. This one is a protocol that we can override the description and debug description, but only, yeah, if we can override the description, debug description. If not, then we need to confirm the custom string convertible. I mean, we can put this description and debug description, and you can distinguish between what kind of data that's sensitive and not sensitive by use the debug description for sensitive data and description for non-sensitive data, basically. So it helps you, but you need to use debug print instead of print to debug your object, basically. So based on these things, conclusion, we know now range selection of debugging options, actually from for memory, from UI kit, from UI debugging, or for breakpoint and everything. You know what to do because I give you some basic knowledge information. If you have something wrong with this, oh, this is happened because UI, so I can turn on the color blended layer. Oh, this is happened because of this constraint issue. You can put some breakpoint on it, symbolic breakpoint. Oh, this is happened because runtime issue. You can put another breakpoint runtime issue, something like this. You have more data to analyze. You still need to have these skills, like say analyzing skills, asking your colleagues, discussing with your colleagues, this is what I found, this is the data I found, A, B, C, D, E, F, G, and everything. You can collect it together, analyze it together. You can have more concrete solution on it. Maybe it's not a good solution yet, or maybe some solution is not that good performance, but at least it help you to find more information. And you can explore more tools. I haven't explored a lot. Uh, there's a lot of things to do. Like I said, option in the instruments is a lot of options. We can explore more by investigate more. We found something unique, try to use something unique, and we can explore more. So there are a lot of good sources that we can use. There's one of Thai person, I think from Ozu. He put like good code, a good post about debugging, and some other things as well. So yeah, I think thank you for that one. So if you have some one question, two question, I'm okay before moving to Fred. So I assume things pretty clear. So yeah, so thank you everyone. I think I will give back to the presenter.
ฮัลโหลเดี๋ยวเราจะมีเบรกกันสักประมาณ10 นาทีนะครับให้สปีกเกอร์คนต่อไปเขาเตรียมตัวก็ทันยังมีพิซซ่าเหลืออยู่แล้วก็มีน้ำมีเบียร์ด้านนั้นนะครับ no coke so we're gonna have a short break around 10 minutes so just wait for speaker to prepare and I still have pizza and beer and water no coke okay, see you at 8 p.m.
Does it work? Hello, hello, hello. Okay. 1, 2, 3, 4, 5, 6. I just start? Oh, okay. Thanks for the introduction then. All right. So hello, everyone. My name is Federico Zanetello, and I am an iOS developer living and working. Well, in short, building Swift packages now is a new way to build frameworks. So this is a project that has been around since 2015. So basically, along with Swift. But since last year with Xcode 11, now Swift packages are supported also in iOS apps. So that's why we are here now to talk about Swift packages on iOS Meetup. And what do we support in here? Well, we support all the normal languages, so Swift or all the language, the C family language. And what can we put inside a Swift package? We can put, of course, code, but also from this year, binaries, assets, and much more. So why should we use one? Well, basically because Swift packages are the new way again to create frameworks. Just so we get all the gains of frameworks just without the complexity. And so let's go a little bit more in detail. So of course, modularization is exactly like on frameworks. So this means that we can create packages with single responsibility. For testability, they also work very well because every single Swift package can create its own tests. So we can, instead of having all the tests in the main app, we can have tests focused exactly on only one single package. So we don't need to have all the tests in one place only. And then, of course, it's going to be much easy to share between different projects and platforms. So platforms, it means in the same project, but also if you want to share a single package across multiple projects, that is going to be easy as well. And we're going to see a little bit about this as well later. And then, of course, it's blessed by Apple. So it means that from now on, probably before you were using some other kind of dependency management, and those are great, like CocoaPod cartridge. Those are perfectly fine. Just from this year, not from this year, from last year, now we have this new blessed Apple way to do things with dependencies. So yeah, that's a very big thumbs up because now this is not a dependency anymore. It's something that comes directly from the source of all the things that Xcode has. And Swift packages are fun. I'm gonna promise this to you. You're gonna see a little bit later as well. And again, they are very easy to use. And those are just some of the points that I'm making. But I'm sure like the more you're going to use Swift packages, the more you will find out by yourself that really there are tons of advantages of using Swift packages. So I hope I've convinced you that Swift packages are great. If not, well, you're going to see it. It's going to be very, very cool. Awesome. So let's get started with Swift packages. First, let me introduce to you my app. So this is a brand new app that I made with the new Swift UI lifecycle. So it's going to be exactly like 2 files. And this is the app that we are going to use today to explore Swift packages. So the first thing that we need to do is create a Swift package. And this takes only 3 steps. First, open your project. Second, go to File, New Swift package. And then name your package and add it to your project. Don't believe me? Okay, I understand that. So let's go through those steps together. So I already showed you the package, the project. So I already opened it. So let's jump right into step number 2. So we go in Xcode, File, New Swift package. Today I'm going to create a library called My Library. So very coherent with the name of the app. And beside the name, I'm also making sure that this package is going to be added in the project of my app. So this is what I'm doing right here at the bottom. And with this, we are done. So really, this is all it takes to create a package. Here it is, among all our files in the Xcode Navigator. But so far, what we did is just create a new package and add it in the project. This doesn't mean that the app currently can use this package yet. So we need to actually embed now the package in our app before we can start using it. And so to do this, we have 2 steps. First, open the app project editor, and then add the package under the frameworks, libraries, and embed content section. So again, I know you don't believe me that it takes so little, but we are going to do this together. So first, open your project editor. This means select your app. So from your project navigator, click in this one. Then make sure that you select your app among the targets. Make sure that you're on the general tab. And then scroll down until you find this framework libraries and embed content section. And in there, just hit the plus button. And that button will show up this screen here where you will see all your frameworks from iOS. And on the top, you will see all the libraries and frameworks that you have available in your current project. So in this case, we just create our package right there, and it's going to be available right here. So we click on that, we click on add, and we're done. Now our package is right here. It's displayed among the things that our app is going to embed when we build and run. And anything that is defined within this package is going to be available for us to use in our main app. So super cool. We create the package. We already added in our app. But really, what did we create? We haven't opened this yet. So what's going on inside there? Let's have a look at that first before continuing. So this is the package structure. So this is exactly what you will see if you open this on your file, on the Finder. And so there is a few things in here. So let's have a rundown from bottom to top. We have our test folder, which contains all our test targets. Then we have our source folder, which will contain all product targets. And as you can see, we already have 2 targets that Xcode created for us. We have a my library test target and a my library product target. And basically, when we talk about targets in Swift packages, you can consider them as their own modules. So each one of those, you can consider them as a module by themselves. And anything that you define within that folder of that target is going to be, all those definitions will be available to all the other things that are within that package. And sorry, to that target. And if you want to expose something outside, so let's say that we want to define something here that is going to be available later on our main app, we need to declare them public, exactly like frameworks. So I think more or less you already know these kind of things. And let's continue here with the exploration of the Swift package. And there is another very big important file, which is a package.swift file. So this is called the manifest file of a package. And basically, as you know, in Xcode, usually when we have a project, we have like all our build settings, all our build phases, all these kind of things. We don't have any of that on Swift packages. Instead, all of those things are defined within this package. So what do we have here? Let's have a look. So this is the package.swift file when you create a brand new project. And in here, what do we have? Well, we have things like the name of the package. Then we have our products. So basically, those are the targets that are going to be exposed for other people outside of the package that they can use. Then we have the dependency of the package, if any. And then we have our targets. So again, those are the targets that Xcode created for us. So we have our product target called my library that has currently no dependencies. And then we have our test target that, with its own name. And as a dependency, it already has the first target has its own dependency because, it needs to see the other target if you want to test it, right? Okay, so this is a rundown of the Swift package. There is one last file that we are going to look at today, which is this file here. So when we create a new Swift package, as you can see here, we already Xcode already created for us this mylibrary.swift file. And what do we have in there? Well, that's all. So basically, Xcode created for us this struct that it's just a struct with a hello world property. I think this is kind of boring, and so let's make something cool instead, right? Like, who wants this? So let's create instead a cool view for our app. So let's get rid of that, and instead let's declare in there a my cool view in SwiftUI. And so as you can see, what I'm doing here is I'm declaring a public struct. I'm making it conform to view. And then here we declare our body. So in this moment, this view is quite simple. It only has a text that says that this view is totally cool. It's going to look very cool later. And as you can see, very important, as I mentioned before, I'm declaring everything public because otherwise those things will be available only within the Swift package, but won't be available to, for example, our app. And if you're wondering why I'm also declaring this empty initializer, is exactly for the same reason, because if we remove this initializer here, from the app point of view, the app will be able to see that this struct exists, but there is no way for the app to actually initialize this struct. So it's very important to also have all the initializer in there when we want to have those things available for the app to use and create. Cool. So now we like this and we want to build our package and see it should work, right? But actually it doesn't. So if we try to build right now, even like we did nothing, it's really simple, actually it doesn't work. And the reason is because we're using SwiftUI, and SwiftUI is a framework that we all know and love, but it's only going to be available from iOS 13 and later. But by default, Swift package are they target anything from iOS 8 and later. So at that point, what happens is that the compiler will tell us that SwiftUI is not going to be available for all the platforms that we currently target. So how do we address this? Well, again, the Swift package manifest file is where we declare all of these kind of settings. So in here, what we can do is we can add this platform argument, and we pass in this case iOS 13, and which means that we target anything from iOS 13 and above. And just by doing this, now we can go back to our app, so to our definition. And if we add the export preview just below here, we will see something like this. So yay, we made it build and we can see something on screen. This is awesome. But now that I'm looking at it, I don't think this view is really cool yet. What do you think? So let's make it a little bit better, right? So what about an image? All right, so let's add an image right on top of the text. And the way we do that in SwiftUI is by creating a VStack, and we embed the text in the VStack. And if you want to have the image on top, we're going to define the image right above it, like this. And as you can see, there is something weird a little bit in there. We have this bundle. What is this? So basically, any UIKit and also SwiftUI APIs, usually what they do is they look for assets in the main bundle, which means the main app. But in our case, we are trying to build a package that is self-contained, that everything is within this package. We don't want to have assets that refer to assets that are outside of package. So how do we do that? Well, we do that by defining this, by adding this argument, bundle argument in our definition. And by saying this, what it means is that SwiftUI will look for this image called cool image within our package, not within the app. All right, so now we have our APIs defined right here. Is this working? Yes. But we still need to add the assets. So how do we add assets on Swift package? Well, it's quite simple. As you can see on screen now, all I'm doing is I'm adding an asset catalog within the folder of my target that I'm using right now. So I'm adding here this asset catalog, and from now on, anything that I'm defining within this asset catalog is going to be available within the package. And we don't need to do anything for asset catalog on the Swift manifest file. Everything is automatically available for us. So we do this, we add our asset catalog, we drop our image right there, and then we can go back to our app, and if we have an export preview just below, we will see something like that. And I think now it's really cool. So now we have a view that is quite nice, and I like to show it to my colleagues, and they come back to me and give me some feedback. So I think now this view is quite cool because I'm an English speaker, but what about other languages? Like if somebody else doesn't speak English, they will see this and they will not think that is cool, and that's not cool. So we want to make this package also localizable, so we can use other languages with this package. So how do you do that? Well, of course, we're going to need to change our text from a string like this. First, we are going to change it to a localized key. And then, exactly like for images, we're going to say that the definition of the string is going to be within our bundle, not in the main app, which again, it means that this full view text localized key is going to be found within the package strings, not within the main app strings. And again, this is completely optional. So this is just for me, in this case, for my package to say, look, I have all the assets here, don't look elsewhere. But in your case, you want to have only one place where you have all your strings in your main app, that's totally fine. Just don't use this. Just pass your key in there and it will work. Cool. But for localization, unlike images, we need to do one more step, which is actually the same that we use also. We do the same also when we are localizing our app in the main, like I don't know, the app in the main project, which is we need to define in the sweep package the default localization. So in this case, I'm telling the sweep package that our main or default language is going to be English. So this is what I'm doing right here. And after this, of course, I also need to add the strings files. So if you go back to our package structure, what I'm doing here is I'm dropping exactly the same configuration or exactly the same folder structure as any other app project right inside my target. And in this case, you can see that I'm adding all of this, not in the root, but on the subfolder called localization. This is completely arbitrary. I'm doing this just to separate the localization from anything else that I'm defining within the sweep package, but it's entirely up to you. But yeah, I think it's nice. It's like more elegant to have things separate in different subfolders. As long as you are within your target folder, it's going to be fine. Like even assets, even other code, you can throw them inside multiple subfolders. Those will work fine. As long as you are within this folder of your target. Cool. And so now that we add our localized key, we add in the sweep package, we define what is the default language. And here we also add Thai. We can go back to our app, to or my code view definition. And voila, now we have Thai as well. So yeah, now I hope it says that this view is cool in Thai. I don't speak Thai. So now we create our beautiful package. We create our cool view. We want to use it. But just before we start using it in the main app, let's talk about testability because sweep packages, okay, not in this case, but usually sweep package, we want to also build, have a kind of test suite around our packages. So how do we do that? So for testing packages, as we've seen before, Xcode already created a target for us. We can add more, that's fine. But going back to the package structure, we see that actually we have a few files in here. So most of those files are here for platforms compatibility. So in case we want also to run or test in Linux and other things, we need those kind of files. But as long as we are building something just for Apple platforms, and yeah, we are an iOS developers here, so we probably want to target iOS, we can get rid of those. And like getting rid of those, I mean, for real, you can just delete them and everything will work fine. And then we just remain with this file. So what do we have in there? So actually, you will see that what's in there is very familiar to all of us because in here we are importing our exit test framework. We are using the testable attribute to import our library. And in here we're defining testing classes exactly like we do already for all our apps in Xcode in the main app usually. But yeah, you can do this and you can add right here as many files as you want. And also Xcode supports all the user shortcuts, so you can use Command U and all the others to build and run your tests. And it will work exactly like the way you're already familiar with. So I'm not going to spend any more time on this. Awesome. So we create our package, we have our view, we have also some testing here. It's time to use the package, right? So we have already added the package, embedded the package in our app. So really what all is left is really to start using it. So what I'm doing here is I'm importing my library because this name that I give to my package. And in here, I'm calling on my content view, my view. And with this, I built and run, and there we are. Now we have our beautiful, cool view in our main app, and everything works as expected. And so this is great. So now we have done everything. Just for your information, if you haven't noticed, our current main app still has like 7 lines of code in total. Everything else is within the package. So yeah, it's very clean, and we can use with packages to really modularize everything in our app. But yeah, this is cool. So now we created packages. What about using third-party dependencies as well? So let's talk about external packages. And as before, we have already seen how little it takes to create and embed packages in our app. So what about external packages? and it's going to be 2 steps. So first we go to File, Swift Package, Add Package Dependency. Then we insert the dependency URL. So we have a Git URL from somewhere, and then we just follow the wizard. That's all it takes. So I know you don't believe me, so let's make an example. So from Xcode, I'm going to File, Swift Packages, Add Package Dependency. In here you will see like your history of things that you look for, or like your own dependency if you have any. And then on top in here, you can actually add another URL that is going to be the URL of your dependency. We hit next. Then Xcode is going to ask us which version of the app of the package we're going to use. And also we can tell the branch even, or the commit, if you want to be very precise on exactly what we want. And also, as you can see here, we have this up to next major. Basically in there, we can let Xcode know if Xcode is allowed to automatically update the package for us. So in this case, up to next major means that I can release another version like 1.2, 1.3, and Xcode will feel title to actually update our package. But if a new version like version 2 or version 3 is going to be released, Xcode will not update automatically for us. It's something that we need to change the rule for, and then Xcode will be able to update. Right, so in here we click next. Then we need to tell in which project, in which target we want to add our dependency. And we're done. So we can go in our project editor again. We select our project. We select on Swift Packages. And in here we will see the list of all our packages that we use, external packages that we use. And in here we can see the version that we're using, the rule of the that we are using for that package, and the location of the package. Not only there, but we can also see the same thing in the project navigator right here. So in here we see again the package name, the version that we're using. And actually, if we go here, and if we click on a chevron and we look inside, in here we have access to the full source code of our package right then and right there. And so, yeah, that's super cool. So you don't need to explore on GitHub or something like this. You can just find everything that you need right here. And so now with that is, how can we use it? Well, exactly like before. So all is left to do is to import our package and start using it and have fun. Awesome. With this, I want to thank the organizer for this awesome opportunity. Thank you all for listening. And please go ahead, create packages, use packages, and again, have fun. Thank you. So I'm going to share the slides and also the main app, the My App project soon on Twitter. Depends on how long it's gonna last this meetup. But anyway, if you have any questions, I'm right here. And if you have some small Coca project, I'm very happy to help you migrate to SPM even right now. So yeah, thank you very much.
Assets catalog for you. And I think what you can do is on the Swift package, you can refer to that package because that is just in the main app bundle.
That probably works from the package itself because it's looking in the main bundle.
Yes.
But the preview will never go onto the main bundle.
Does it? Okay.
No, unfortunately not. You even change the key to the to your library. Yeah, to the package library.
Okay.
And then you totally limit. And there's one more issue. You're having more than one Swift package. Let's say you have library A, library B, library C. And library A depends on B and C. And you start to build your Swift package in the preview. It's library C. It works perfect. You go to library A, and it accidentally links all libraries to library C, to A, and you can end it up that the preview is not working and you use duplicated symbols. I haven't figured out how to avoid this help of linking.
Yeah, good luck. Yeah, usually like if I work with one package, I really is great. But yeah, in this case, when you start having like a package dependent on other packages, maybe I should still have some rough edges. It's going to improve. Please find feedback. Yeah, good. That's what I can suggest for the moment. But yeah, besides that, like if plug cities on, they don't work very well. Like there's no way to have like debug or find the target itself. Yeah, it's not like a complete replacement of frameworks, right? Like just now, but it's going to be. So, but yeah, maybe still we have some little advantage in there.
One more question for you. Have you used Swift packages, this external repositories, to put your own Swift packages on GitHub or Bitbucket or whatever? And did you use multiple versions of your app, or do you have only one packages per app? So what I mean is, let's say you have 5 packages, 5 different cool features, independently, and you put them on GitHub. So you have 5 modules, and if you're importing them into Xcode, you have the possibility in Xcode to edit them by adding them locally into your project. How do you commit them? You say you're changing multiple repositories. How to commit them at once? Do we have any
At
tools?
once?
Yes, this is my problem. I split it kind of app, a sample app, multiple modules. Now I have 5 repositories, and I usually make changes nearly every time. Now I need to commit 5 different repositories. How to manage this?
That's probably one of the big package.
Okay, nice.
I'm doing that in my own app as well. Yeah, because it's 5 different kits for the moment.
Yeah.
So the only way to commit all of them at once, unless you write your own script with that, but otherwise, yeah, I don't see an easy way to do that.
If I commit them in one, and I have problem, I cannot versioning like these, but I have only one version number. Right? You don't want this one if you're splitting it in different modules.
What do you mean? Like the check is another thing, like committing and checking.
Yeah, but if you're putting it in one repo, it has only one version number. The repo can be
Oh,
checked
yes.
out as one version number. Well, okay. You see, a lot of things.
Yeah.
Okay.
Thank you very much.
What if we put the wrong asset name? Let's say that asset name is not in the module asset.
What's the error?
What's the error? It will not go to the main bundle or
I understand. I will difference.
Yeah.
I think it will fail. Currently, I don't think it will go to the main. Because you are expecting to say, look for keys in the
like
module
image name,
bundle.
and then that the image name, and I say that into this module, right? As you show in the
Yeah.
example, but I accidentally put that image to the main bundle. If
Yeah.
you go to the main bundle, it just crash.
I haven't tried. I think by the folder place it will fail. Have a look at the APIs. Actually, I'm using just the bundle parameter, but I think there is a ton more parameters. So maybe there is a way. I have no idea. Let's explore it.
They have the option to go up the main bundle, but I think if you specify in module way, expecting it in the module, you need to do it by yourself.
Yeah.
And it will just crash.
I think it have return the as a no bundle basically, as a no image.
Yeah, by default, I'm pretty sure that is going
Yeah.
to be the behavior. But yeah, explore and see. The other thing you can do is create your own image, and then within the image you do that.
Yeah.
This where you check, oh, is this in this within this module or not? Then go back to the main bundle.
What is your take on adopting VM into Android?
So do it. I've been using SVN since last year, and like in this moment you won't find all the dependencies that support SVN yet, but even Firebase now support SVN. So like within a few months, hopefully, you will see that most of the libraries, especially new ones, they will just support SVN. They will not even bother to go to Copilot or other things because yeah, we have a less way. and you can use them without any issue. Like you can have a app with some dependency on cartridge, some dependency on protocol, and some in SVM. That still works fine. You should choose only one of them, possibly, but during the migration, it's totally fine to use, like let's say, protocol and SVM at the same time. And slowly, you will see that you can move some of the protocol dependencies to SVM. And by moving them, I mean just you delete from the code file the reference to that dependency, and you add it the way we saw here today to among the in your app, and then you keep building and it will work. So yeah, it's not very hard to migrate, but yeah, please make sure that your dependency actually supports it. And it's very easy. You just need to find on the root file the package.script file. It's in there. It should support the SVM. Otherwise, if it's not there, they haven't integrated yet. And actually, if you start using them, you will see that it's not too hard. So in case you have a dependency that still doesn't support SVM, take a pull request yourself. It's really not that much hard to create a package with it. So yeah. Any other questions? Awesome. If you want, I will be here. I will hang out. So if you want to ask questions privately, that's also fine. Thank you very much again.